All right, good morning. So we're going to talk about inverse trig functions today. Okay, so let me go ahead and share my screen. Okay, and let's go ahead and take a look at what's going on here. I think we can get this done in about 2 videos, so we'll try that. All right, so you recall what the graph of sine looks like. So if I have a y equals sine x, okay, let's take a look at what's going on here. So right, here's our 2 pi, here's our pi over 2, 3 pi over 2, right? We have a 1, we have a negative 1. So here, 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 and here. And we'll just push this in here, okay? All right, there's our sign. And remember, this does go off in infinite directions. Okay, so I want to find an inverse function. One of the first things you should look at when you're saying, I need an inverse function, is to realize that this fails a very critical test. This is not a one-to-one function. This fails the horizontal line test. Okay, so very similar to what we did when we were looking at an inverse function for the square root function. Okay, so if we have the square root function, we say, well, what's the inverse, right? And then we do square root of y is equal to x, right? Swap the x's and the y's, and we say y is equal to x squared. And most of you said, wait a minute, we have a function that is, right, not one-to-one, it fails the horizontal line test. And the way we got past that, okay, was to restrict the domain and say, well, what if we only think about x being greater than 0, greater than or equal to 0, or x being less than or equal to 0? So we would only have like one of these legs to stand on here. Okay, we wouldn't have both of these arms coming up. We'd only have one of them. So that actually worked pretty well. So in this case, I would like to come up with negative pi over 2 rather. I would like to come up with a region, okay, in here. Preferably, I'd like to include 0. Okay, it's always a good thing to have a 0. But I would like to have a domain that is one-to-one. And you know what? This one right here does that. So if we restrict our domain of sine between negative pi over 2 to positive pi over 2, okay, then the graph we're going to see, okay, here's pi over 2, here's negative pi over 2. The graph we're going to see is going to be here and here, okay? So we have a one-to-one function now, passes the horizontal line test, okay? So now we can have an inverse, okay? So we're going to say y is equal to sine x on the interval from negative pi over 2 to pi over 2. What's the range here? Okay, this is my domain. What's the range? What are the legal values of y? We go from negative 1 down here to positive 1 up here. So negative 1 to positive 1. Okay. Now, do you remember what the relationship was, the domain and the range of one function to the domain and the range of its inverse function? Right? And they flip-flopped. So we'll call this f of x here for the moment. And we'll say f inverse, right, is going to be the inverse, whatever function that is. Okay, sine's inverse. We're going to say, well, the domain here is between negative 1 and positive 1. Okay, and the range, right, is negative pi over 2 to positive pi over 2. Okay, so remember, these are our y values. These are our x values. All right. So we're going to do that. We're going to say, well, we're going to say f inverse, right? The sine's inverse. We're going to say this is, in my book, they capitalized it. I don't think very many people do that. Okay. But that you know, we don't have to capitalize it. If you don't want to, that's okay. I'm used to it, so that's what I tend to do. But there's an older notation called an arc sine. Okay, and this is also the inverse sine. All right. So because I need LaTeX and special editors to do this, okay, to put that exponent where I want it. I will often use arcsine to signify what's going on for inverse sine, okay. But these are both they're both pretty common notations, so you really should know both of them, okay. So there is that's our inverse sine, okay. Now we know what our domain is, we know what our range is, okay. So we just go back to this. We say this is 0. Actually, let's do the problems, the values we want. Okay, so we have negative pi over 2, 0, and pi over 2. Now this is for sine. Okay, this is just for sine. So at negative pi over 2, right? That's down here. The value is -1. Okay, at 0 we are at 0, and at pi over 2, sine of pi over 2 is +1. So again, we change the domain and the range. Okay, so sine inverse, these are now my x values, those are my y values. Okay, so when we go to graph this thing, right, our x values, here's -1. What's the value of inverse sine at -1? Negative pi over 2. So here's 1, here's negative pi over 2. All right, when we're at 0, we're both at 0, pi over 2, right? Well, at 1, we are at pi over 2. Okay, so there's 1, and there's a positive pi over 2. Okay, and that is approximately what this thing looks like. Okay, don't take my word for it, because I have really crummy drawings. So we'll go ahead and we'll turn on Desmos for a moment, and you can have a look and see, like, what does sine inverse look like? All right, so it's kind of like a cubic, but not really. Okay, it's not, but it's got this limited domain. Okay, this is something you're gonna be haunted by. Okay, this is going to be a tough part. So you can't just say like the inverse sine of a sine is equal to that angle. Okay, you have to actually go through and perform it, because the sine technically doesn't have a restricted domain. Okay, so you're gonna get a value, right? You're gonna get a ratio, and you're gonna feed that to inverse sine, and it's gonna give you a new angle. Okay, so realize this is what we're doing. Okay, so sine. Okay, I'm going to use theta because that's my usual symbol for angles. So sine takes an angle and turns it into, right? It turns it into a ratio. Let's go ahead and be consistent with our notation here. Okay. Ratio. Inverse sine takes a ratio and gives me back an angle. Okay, so it takes the ratio and returns the angle. All right, so it's important to remember that. So if we take, like, say, sine of, let's do something in the fourth quadrant. Okay, how about -7 pi over 4? Okay, so if we look at where is -7 pi, or just 7 pi over 4, we already have negative. So if we take 7 pi over 4, right, here's my angle. What is the sine of this angle? We're going to get in radians. Okay, in radians, we're going to get negative square root of 2 over 2. Now, if I feed negative square root of 2 over 2 to my inverse sine, take a look at what's going on here, right? Negative square root of 2 over 2 is about 0.7-ish. I should have picked something in the third quadrant. I'm sorry. Let's pick it in the third quadrant. Ugh. Sine of 5 pi over 4. Okay, so again, here's 4 pi over 4, here's 5 pi over 4. For reference angles, how much more do I have to get back to a horizontal? It's pi over 4. Okay, so the sine of pi over 4, right, that's square root of 2 over 2. but it's in the third quadrant, negative. Okay, so we want to do inverse sine of a ratio, negative square root of 2 over 2, and equals. So let's look at our graph, right? So our ratio was about 0.7071, so we'll call it right here, okay? And then we are going to have something value in here, okay? But I'm just looking at the graph. Okay, here's about 0.7-ish. And then down here, we're going to get this angle, okay? This angle's in the fourth quadrant. Okay, but wait a minute, we said inverse sine of what we did for a sine. Shouldn't we get the same thing back? No, because the sine is going to take whatever, it's going to be able to take whatever angle you give it and give you back a ratio. But the inverse sine is only able to take certain ratios and give you back angles. So you have to be real careful, like what angle am I actually looking for? And you may have to adjust, okay? Because this, look at your calculator, okay? So I'm going to go back to degrees for a moment because I want you to be able to see where this is, okay? And it's easier to think in degrees than it is in radians. So we're back in degrees. Okay, so I want to do second function, sine to the -1. That does not mean cosecant. Okay, this is undoing the sine. Okay, it's not 1 over the sine. The button for over the sine is this one here where it says reciprocal. You don't have a cosecant button. You have to figure out like 1 over sine is. Okay, so this is going to be, I'm just going to type in, right, negative square root of 2, parentheses, over 2, and parentheses. Okay, and it gave us negative 45 degrees. Where is negative 45 degrees? It's here. Okay, this is negative 45 degrees, or negative pi over 4, or 7 pi over 4, depending on how you want to represent it. Okay, what's the angle we started with? The angle we started with, okay, is this one. All right. We did get back the same thing. So we did, this is what we, usually with an inverse function, you expect, right? If I do sine inverse of sine of 5 pi over 4, you would expect to get 5 pi over 4, right? But you don't. You don't get that. Okay. You get negative pi over 4 or 7 pi over 4, depending if you want it represented as a positive or a negative answer. So you have to take this angle and recast it to where you want. So if there's a physical context to it, you have to be able to interpret this angle to be the angle you actually wanted. Okay, so don't just take this to say this is what's going to happen, because it isn't. Okay, the homework goes over this and does some problems like this where they try to fool you. You know what the trick is. You know what they're trying to fool you to do. Don't get fooled by it. Okay, you should be aware of it. It's like, Admiral Akbar there. It's a trap. It's a trap. Don't do it. Okay, so I'm going to show you what the inverse arc or cosine is. Okay, it's a very similar argument that we're going to do here. So when x equals 0, cosine is 1. Okay, and you can see what this is going to look like. Now, all of the trig graphs, you have to know those. Okay, for sine and cosine, to be honest, I never memorized them. Okay, I would always be able to kind of reconstruct them as I needed them, but I never memorized them. Okay. By the way, cosine. Okay, let's look at cosine. Cosine, I can't do between like negative pi over 2 to positive pi over 2. Like, why? That was a horizontal line test. So the domain for cosine that we're going to use is going to be between 0 and pi. Okay, range is, again, -1 to +1. Okay, so inverse cosine, I will use arc. Arc cosine, the domain, right, still is -1 to 1. Okay, but the range is 0 to pi. Okay, so here we're working in quadrants 1 and 2. Okay, we're working here and here. Okay, so again, if it gives you an angle that's in quadrant 3 or quadrant 4, you're going to have to reconstruct this, okay, to get the angle that you actually are looking for. Okay, tangent is cool. Inverse tangent. Okay, here's what inverse tangent looks like. Okay. If you remember, inverse tangent has an asymptote, right? There's negative pi over 2 to positive pi over 2. So it's got an asymptote here. Okay. It is, I think, the first function you actually meet that naturally has 2 horizontal asymptotes. Okay. So tangent, inverse tangent, the domain, okay, negative infinity to positive infinity. Okay, we get it that way. The range is going to be negative pi over 2 to positive pi over 2. It's got 2 horizontal asymptotes. It's got a horizontal asymptote at y equals pi over 2. It also has one at negative pi over 2. Okay, if I scroll that a little bit more, you can kind of see that a little bit better. Okay, there's a couple of, I mean, mostly they're involved and related to tangents to see whether or not they are have 2 asymptotes. But these actually do have 2 horizontal asymptotes, and they just occur naturally. So you have to be a little bit careful with that. So if they ever told you, like, you can only have one, like, no, you could have more than one. Okay, you could have 2. It's not going to have 3. I mean, it could. No, it can't have. It could. We have to really go out of our way to do that. Okay. How would we make that happen? Okay, we'd have to have something like, you're not going to like this. Okay, we have y is equal to arctan x if x is a rational number, and then y is equal to arctan of x plus, let's see, pi over 2 is about 1.7, so let's go to like plus 3. Okay, so it's a vertical shift of 3 if x is not rational. I can't draw it for this. Okay, what it's going to look like is just going to be it's going to be our inverse, our arctangent. Right, here's pi over 2, and then here's 3. Okay, so it would look something like 3 minus pi over 2, so something like that. Okay, but you need this piecewise function in order to get 4. Okay, and I guess we could just keep constructing them. Okay, just taking out like weirder versions of irrational numbers to do it, because it's still an infinite number. But unless you're taking like a class that comes after calculus, it's called analysis, nobody is ever going to expect or want you to do this. Okay, it's just not happening. Okay, but analysis tends to say, well, what if I break all the rules? Okay, they say you do it. Okay, we didn't break any rules. We just looked like we did. Okay, so that's our tangent. I'll show you the other ones. Okay, but understand, like, we don't really use, like, I don't think I have ever used an arc secant, okay, or an arc cosecant. Let me go ahead and do this. There we go. Make it a little bit darker to see. Okay. And we'll get rid of arctangent. Okay, so that's arc secant. Okay, like I said, I've never used an arc secant. I don't have a button on my calculator for an arc secant. So you just say 1 over arc cosine. Okay. Even that, no, that's not going to work. Okay. Never used it. So I would not recommend memorizing this one. It's something that's there if you really need it, but we don't really work with it. Same thing with arc cosecant. Okay, I'll turn this one off so we can see it. Okay. And while there's nothing wrong with arc cotangent. Okay, there's nothing wrong with it. It's got the same kind of neat sort of, here's two vertical or two horizontal asymptotes that's going on here. To be honest, like most people will just use tangent rather than cotangent. So we do have this, it will be in the homework, but I'm not inclined to ask you a cotangent problem simply because most people don't like cotangents, and I'm the same person. Okay, not a big fan of our cotangents in general. Okay, but it's there if you need it. Okay, and that's what an arc cotangent would look like. Okay, you might want to memorize what arctangent looks like simply because it does come up. Okay, you may want to at least be mindful enough of arc sine and arc cosine so you could recognize them. Okay, if I had to pick one out of a lineup, hey, that's arc cotangent there. Okay, but as far as the arc secant, arc cosecant, and arc cotangent, remember there is such a thing, and then remember things like Wikipedia exist. Okay, I would not go out of my way to memorize what these look like. Just know that they exist and that you can type them into Desmos and get them. Okay, they don't happen often enough for you to need to memorize this. Arctangent does happen often enough that you would want to memorize, and arc sine and arc cosine do happen often enough that you want to at least be aware of the pitfalls around them. Okay, and we're going to go explore that in the homework. Okay, so that's just what the graphs look like, and we're going to get to some doing some homework here. All right, so let me get out of this, go back to here. Okay, and we want to find the exact value that is specified. All right, so if you memorized your basic unit circle, at least first quadrant stuff for the unit circle, this is going to help. Okay, you can do this in the calculator, but since it's going to say give me your exact values, you got to recognize the exact values to know like what it's really talking about. Okay, not saying I ever memorized that square root of 3 over 2 looks something like 0.8661, but it did pop up once in a while. So if you are inclined to memorize numbers like this, then that you can do that. But what would be better is if you knew the unit circle well enough to not worry about it. Okay, so remember this. See, they use arc sines. Arc sine of negative square root of 2 over 2 is equal to. Okay, now this is going to give us an angle in the fourth quadrant, right? So you have to also remember, like, arc cosine takes, or arc sine rather, takes a ratio and gives you back an angle. Okay, and it's a really important thing. If you have to write it down a little bit to kind of keep yourself straight, then by all means do that. Okay, so arc cosine of negative square root of 2 over 2, this is going to give me back, right, negative pi over 4. Okay, that's the angle. Okay, and I don't know if they're going to care. So we're going to say negative pi over 4. They didn't say give it to me as a positive angle. So let's check. Okay, it was okay. They were okay with that. So, because you at this point know that connect math can be picky, would not be the problem, would not be the word to describe it. Okay, think of something far more extreme than picky. Okay, but that's the kind of thinking they want you to have for this. Okay, tangent inverse of negative root 3. Well, tangent of what angle gives you root 3, right? And that was pi over 3. Tangent, right? This goes from, right? Tangents look like that. Okay, so it's negative pi over 2. I'm sorry. Yeah, negative pi over 2 to positive pi over 2. So inverse tangent is going to give you a quadrant 4 or a quadrant 1 angle. Okay, since it's negative, we have to pick quadrant 4. So we're going to go with negative pi over 3. Okay, so negative pi, pi over 3. All right. Find the exact value of this one. Okay. I actually really like this problem because you can put like a bunch of them in here. And I don't like putting like a whole 6-point problem like this, but what we're going to do is we're going to say this is our ratio, right? We're going to say this is equal to some y. So we're going to say cosine of both sides here. Okay. We're not really doing this, but we are doing this a little bit. So we're saying what angle, cosine of what angle is equal to -3? And what's the graph of cosine look like? +1, -1. Here's the graph of -3, y equals -3. Does cosine ever meet this line? Like, no. So this is outside of the domain for our cosine. Okay. So this is undefined. It went outside the bounds. We don't worry about it. Okay. And we're just going to move on with our lives. Okay. So let's see here. Aha. Now, use your calculator to approximate the degree measure or radian measure. Notice my answer is given. The domain of my answer is given from 90 degrees to 180 degrees. The answer is going to be in degrees. If they gave me like pi/2 to pi, the answer would not be in degrees. It's going to be in radians. Okay, so you have to be careful. Like, well, they're asking me a question in French. Maybe I should answer their question in French. Okay, they are not going to be happy if I answer in Korean. Okay, so we have sine of theta is equal to equals 12/19. Okay, so what we're going to do is we're going to take inverse of both sides. We're going to say sine inverse of the sine of theta. Okay, this is more of a symbolic manipulation sort of a tool rather than a actual answer I'm looking for. On the other side, we'll do this and then figure out where we have to be. Okay, so it's not when I get this answer, that's not my final answer. Okay, so are we in radians? I don't think so. So we're going to go to mode, radians, select that, quit. And then we're going to say inverse sine, okay, of 12 divided by 19. Oh, wait, no, it should be in degrees. Let me go back. Mode, degrees, done, quit. And I will go ahead and do that. Okay, and they said 39.1667 degrees. Okay, how many decimal places do they want? Right. 1 degree, one decimal place. Okay, so this is 39.2 degrees. And they said it has to be between 90, right? So here's the answer I got, somewhere around 40 degrees, right? 39.2 degrees. But they said it has to be between 90 degrees and 180. So it's got to be over here somewhere, right? How do I get this answer? Well, what if I take 180 minus 39.2 degrees? Okay, because this angle, okay, let's go ahead and give myself a different color here. This angle, okay, and that angle, those are supplementary degrees, aren't they? They're supplementary angles. So 180 minus this will give you this one, which we could just rotate and end up with. You could just end up with, put it back in standard position, right? We're going to end up with that one. Okay. So that's what we want. Okay, so 180 minus 39.2 is going to be like 140, 141, or 140.8. Okay, I think. Do that. Now, if you're unclear, right, what's 12 over 19? Take a look at that. Okay, double check our answer here. So sine of an angle equals 12 over 19, which is approximately, okay, which was approximately 60.632. It's not going to be exact, okay? So if I'm going to go ahead and take the sine, right, I want the sine of 140.8, okay, because both of those angles should give you the same ratio. Look at that, 0.632, okay? So there's a way to check your answer if you're not exactly sure, okay? You take the inverse sine, get your angle, adjust it, and then take the sine of that angle. Did I get back what I needed to? Yeah. So our answer that they're going to want here is 140.8. Right? So there we go. Did they want more? They didn't want more. Okay. Tell you what, I'm gonna stop this video so it'll stay shorter, and then we'll just do the rest of these. Okay, so it'll be a 2-video sort of a thing here. So stay tuned for the rest of your homework. It'll be up in just a moment here. It'll be the next video in the line, I should say. All right. So exit, end.